Bismillahirrahmanirrahim. Welcome to Glenrich Maths. Today we are going to solve a logarithmic questions, and the question belongs to 060622 for the session October-November 2024. And I have written here my WhatsApp number. If you want me to solve any complicated problem, please let me know through this number. Let's see today's question on logarithm. This is question number 5 of the mentioned paper. Let me show you the question, zooming it out. The question is actually, yes, question number 5. Log x square of 2 based log plus x of 16 based log is equal to 18. Before we get into the solution, just let me inform you, though I know that all of you know it. Whenever it is written log, then there is base, then this is we usually call it number, then above that there may be another one which is exponent. So here this 2 is called the base. 2 is base, x is called argument. X is called argument, and this is called exponent of the argument. So you can read it out as 2 based x raised to n of 2 based log. Well, let's go back to our solution. So this is our question. Then we have written the first quantity. First log has been written unchanged, x square of 2 based log plus. Now look at this. In case of logarithm, always we try to get the same base. If we can convert into the same base, then rest of the part is nothing but easy. So the first one, for the first log, base is 2, and we are going to convert the second one also of base 2. How can it be written? Let me show you with an example. Suppose, let me write over here. Suppose you do have log a based b. Okay, now if you want to convert this a b of a based log, then you can write it simply. We will form a fraction. Suppose we want to convert it into 2. Base should be 2. Okay, base we are converting to the log of base 2. So how will we write log 2? Log 2 in the numerator as well as 2 based log. Okay, look, we are trying to convert the base into 2. So first of all, what will we write? In the numerator the 2 based log, in the denominator also 2 based log. Now in this one, this is the argument. Okay, argument should be on numerator, and your base, the former base, will be the denominator as argument. So what should we do? First we will write the base we are searching for, or we are going to convert into. So our here we have supposed our base is 2. Then argument, this will be the argument of the numerator, and the base will be the argument of the denominator. So this is as simple as this. Let me explain once again. First of all, what do we write? We write both the numerator and denominator with the required base we require. We require base 2. Suppose we are converting to same base of 2. Then that log base of 2 has been written 2 base log in numerator as well as in denominator. Then the argument of the question comes over here. This is the argument of the numerator. So the argument becomes the argument of the numerator. Then the base become the argument of the denominator. It is a. So this is how we can convert. If we go back to our question, then we will see it is as exact as I have shown. So first argument, look, our base is 2. We are, because first base was 2, that's why we are going to convert into 2 based log. So first one is unchanged. In the second one, we have written same base, log 2 based log 2 based log here. Then this argument, look, this argument has been the argument of the numerator, and the base has become the argument of the denominator. Once again, the argument, given argument, remain unchanged. This argument, this x has remained argument again, but this base has become the argument of the denominator. This is how we can convert any log of any base to a particular base. Well, then we have done here. First one, look at this. This exponent is actually the coefficient. Okay, exponent is always the coefficient of log, so we have written as coefficient, and 2 base x of log of base 2 is unchanged. Then here what have we done? The numerator is unchanged. This numerator, this is unchanged. In denominator, you know, these 2 based log of this 16 can be written as 2 raised to 4. Look, so this argument is 16. This 16 can be written as 2 raised to 4. Have you got this? Because 2 raised to 4 means 16. So this 16, the argument has been split into its prime factor. So have you understood that 16 can be written as 2 raised to 4? So ultimately our argument is same. Argument was 16 and still it is 16, means 2 raised to 4. Let me show you the next part. So in the next part, look, the first logarithm, first log is unchanged. In the second one, look, it was, what was it? Let me show you. It was, if you remember, it was log 2 base is 2 and argument is 2 raised to 4. And we know a formula: if base and that argument are same, the value is 1, isn't it? Or in another way, it can be written, look, the exponent of the argument is actually coefficient. Then there remains 4 log 2 of 2 based log. Okay. Now this one, if the base and argument, if the base and argument are same, then the value of that one is 1. Okay. So this is a rule we are learning. If the base and argument of any log function is same, if base and argument of the log function is same, then the value is 1. So there was 4 over here, and this 2 based log of 2 is also 1. So 4 ones are 4. That's why our denominator is 4. Denominator is 4 and numerator unchanged. Well, then here it has become 8. All of them, if we multiply everybody by 4, on left, right, every side, let me erase these unnecessary parts. Since this is an equation, and there is a denominator as 4, so let's multiply every quantity by 4. So if we multiply these by 4, what will it be? 4 2s are 8. If we multiply these by 4, it will be 4 will cancel out this 4. So the first one will be 8 log 2 based log of x, then again 2 based log of x, or x of 2 based log, equal to, then if we multiply this by 4, it is going to be 72. So ultimately we have got 8 log 2 based argument is x, whereas 8 log 2 based argument is x, equal to 72. Now look at this. Suppose this one is our a. Suppose this is our a. So this will also be a, isn't it? This is an a, this is another a. So this is 8a. 8a plus a means 9a. So this is our a. Okay, so 9a. We have supposed it to be. For your easier conception, actually, I am telling that if you tell that 2 base log of x is a, then this is 8a plus a means 9a. So a means actually our x of 2 base log. Then if both side is divided by 9, it is going to be if it is divided by 9, it will be 1, it will be 8. So on the left side there is only x of 2 based log on the left side, and the right side there remains 8. Now we are going to learn another concept of logarithm, that is fundamental concept of logarithm. If the question seems to be this, suppose this is a question, log base is b and argument is a equal to suppose m. Okay, so what will happen, actually base can never be changed. It's equal to, base must not be changed. So our base is b, and this is actually they replaces each other, they goes and come back. Okay, they replace the argument and the right side, they replace each other. So if they replace each other, then first of all base should not be changed. Remember, base is still base, and they are interchanging each other. So instead of a, it is going to be m, and instead of m, it is going to be a. This is what the concept is. So once again I am repeating that, look at this, base should not be here. Base is how much? Our base is 2. Okay, so base should not be changed. Then this x and 8, one is argument, another one is integral number on the other side, so they will interchange each other. Okay, instead of x, I mean instead of argument, it is going to be the number, and the number has been converted to argument. So simply our base is 2. 2 has remained unchanged, this 2 has remained unchanged, and they replace each other. Okay, so x is equal to 2 raised to 8, that means x equal to 256. I think you have understood. Now let's talk about question number b. B says, this is what b is. B is e raised to 2x plus 1 minus 10 e raised to 2x minus 1 equal to 3. Well, so the first equation, I mean first quantity, we have left it unchanged, and in the second one, look at this, it is given that there is a negative symbol in front of the exponent. So we can just take negative symbol as common. If we take negative symbol as common, then there remains 2x plus 1. So first term is unchanged. In the second case, what will happen, look, if we get a and our exponent is negative or surd or whatever, then suppose this is 2, how do we write? We write 1 over a square. That means negative exponent means that is the denominator of the fraction. Well, if it is a inverse of 2, then how do we write? We write 1 over a raised to 2. So similarly here also 10, there is no question about 10. Look at this, above 10 there is no exponent at all, so 10 is numerator, so 10 has been written as numerator. Now this one, the exponent is negative. Okay, as exponent is negative, it will go down as denominator, so e raised to 2x plus 1. Then let me expand this or explain this through expansion. For the next step, we have come to know of this step. This step has been learned by us, we have learned. Now about this step, how can it be? Let me show you over here. Let me write, it is a raised to, what are we given? We have been given e raised to, suppose this one, e raised to e raised to e raised to 2x plus 1 over, then minus or plus. Let us see, was it minus or plus? It was actually minus. Yes, this is minus 10 over 10 over 10 over e raised to 2x plus 1 minus 3 equal to 0. How to do this? We will just simplify this, or if we, as this is an equation, we can multiply both the sides with something. Let us multiply everyone by e raised to 2x, or suppose this is x or a. Okay, this is, then it will be 10 minus a minus 3 is equal to 0. So if we multiply every quantity by a, what will it be? A into a, and this will be 10 over, sorry, minus 10 over a, and we are multiplying by a. If we multiply this also a by, then right side will be 0 multiplied by something, it's 0. So what is it going to be? It is going to be a square, and this a can cancel out, that another one, minus 10 minus 3a. Okay, minus 10 minus 3a. If we write this, a square minus thrice a minus 10 is equal to 0. You know, this is a quadratic function, so we can factorize this, splitting the middle term. If we split the middle term, it will be 5 to the 10. So a square minus 5a minus, sorry, plus 2a minus 10 is equal to 0. After that, what will happen? We can take a as common from the first pair, and 2 can be taken as common from the second pair. If we take, it is going to, so again, a minus 5, a minus 5 is a factor, and a plus 2 is another factor. A minus 5 as well as a minus, sorry, a plus 2 is the another factor. So we can factorize in this way. What have we done? Actually, we have supposed this portion, sorry, this portion has been supposed to be a, just this one has been supposed to be a. Okay, then we have written a minus 10 over a minus 3. Then both sides have been multiplied by a, both sides have been multiplied by a. If we multiply a by a, this is a square, then it will be minus 10 and minus 3a. So it's exactly same, just we have supposed this a raised e raised to 2x plus 1 as a. Then finally you have already seen, by it is a quadratic function, so factorizing this, we got that a minus 5 is one factor and a plus 2 is another factor, and our a is what? Our a is e raised to 2x plus 1. The same function has been factorized in our solution. Let's see what has it become. It has become just this way. Look, e raised to, this is e raised to 2x plus 1 whole square, 3 a raised to 2x plus 1 minus 10. So, and we have supposed it to be a, this to be a. Okay, so a square minus 3a minus 10. Ultimately, what did we get? We have got that this is a, this is our a. Okay, this is a, this is also a, this is a, this is a, this is also a. So we can, from the both first pair, from the first two quantities, this a is common. If a is taken common, there remains this a into a minus 5. And if I show it more clearly, look at this, from the first pair, though it has already been shown, again I am showing, in the first pair, look at this, this is the first pair of quantities, and this is the next pair. In the first pair, e raised to 2x plus 1 is common, so we have taken this as common. If e raised to 2x plus 1 is taken common, as this is square, another one is there. Then from this one, from the second quantity, if e raised to 2x plus 1 is taken common, then there remains only minus 5, we have written here. And from the second pair, if 2 is taken common, it will be e raised to 2x plus 1 minus 5. And these two factors are same, as I have shown in the previous explanation just a few seconds back, that it is actually a minus 5 and a plus 2. Simply our a is what? A is this one, okay? This one you may remember that it was what? It was our a. So a minus 5 and a plus 2. Just like the explanation. So we have got two factors. One is e raised to 2x plus 1 minus 5. Another one is e raised to 2x plus 1 plus 2. Then as there are two factors, let's see whether both of them are logical or not. This one is e raised to 2x plus 5. We have chosen the first one. But why did we reject this one? Let's see. This is e raised to 2x plus 1 equal to 0. Initially what can come to our mind that this is equal to 0, but it's not 0 at all, because this neither of this is negative. Both of them are 2 is positive. This one is also e is Euler number. Okay, so Euler number is, if this is exponential number, exponential number can never be negative. So if both of them are positive, how can it be 0? So it doesn't make sense. That's why we rejected that. E raised to 2x plus 1 is greater than 0. It cannot be 0. We have rejected this. So there remains only the first factor. First factor is e raised to 2x plus 1 is equal to 5. And then we are going to borrow loan on both sides. Let me show you. Suppose this is something like the exponential function. Okay, exponential function, let us write a raised to x equal to 5. So how to solve this exponential function? We will borrow ln on both sides. We have borrowed ln on both sides. It's ln 5. Okay, so what will happen if this is like this? Then this is our, here base is actually ln, for natural log the base is actually e. Okay, so exponent is, I mean argument is a, base is e. Well, so this is how we can write. We have just borrowed ln on both sides. Now if ln is borrowed on both sides, what will happen? Look at this here. We know that ln, if the base and the argument are same, then it is equal to 1. So this is one concept we have already learned. When the base and argument are same, then value is 1. So here look at this. For ln means the base is e, base is e, and argument is also e. So ln e based e of ln e base, or e of e based ln log, that is actually 1. So this is actually 1. So when base and argument are same of any logarithmic function, then that is 1. And ln means actually here base is e. Ln means its natural log. So then if this is 1, so it will be 1 into this, into 2x plus 1. So 2x plus 1, 1s are 2x plus 1. On the right side it will be ln 5. Then if 1 is shifted to the right side, it is ln 5 minus 1. So ultimately our x, if 2 is shifted also, 2 will go down. This 2 has gone down. X is equal to ln 5 minus 1 over 2. And using your calculator, you will find that x equal to 0.304 something. And after rounding it up to 3 significant figures, then you will get this. So what have we learned here from here? Let me erase all unnecessary parts. This is the whole of the solution of a and b. In a we have learned a concept that we can convert any logarithmic function into our required base. Like as I have shown, suppose this is a question is log, base is a, argument is x. So we can convert it into a different base. Suppose it is 2, then base, the same base will be in the numerator as well as denominator, because we require this base. Then the first argument will be on top, numerator, and the base will be the argument of the denominator. This is how we converted. This is the one concept we have learned from the first question. And from the second question, we have learned that e raised to ln, in case of ln, this is natural log, that is base is e, and if argument is also e, this is equal to 1. And always the exponent of the argument, suppose log or ln, sorry, log 10 based log, okay, 10 based log, if log is mentioned then base is 10, and this if argument is also 10, and here the exponent always comes at the front as coefficient, so it will be actually 2. 10 of 10 based log of 2 is 10 square of 10 based log is actually 2. So these are the two concepts we have learned from this, and thank you all for watching the video. Allah Hafiz.